Welcome to Security Weekly. I'm your host, Matt Alderman. We're at day 2, recording live at Black Hat 2019. We're in the suite at Mandalay Bay. And joining me for this segment, Jeff Hudson, CEO at Venafi.
Matt, good to meet you.
Nice
How are
meeting
you?
you. Yeah, last year you did this at the Pool Cabana with Paul.
125 degrees
Right.
on the deck. It was
Yeah.
insufferable. I was dressed like this. I wanted to be in my shorts, but I was kind of gentrified guy. And it
Yes.
didn't work out so well.
That's why we're in the suite this year instead of down at the pool.
Thank you for that.
We learned our lesson very, very quickly and thought this was a much better place to be. This year we're going to talk code signing. And I want to start a little bit with the problem because, code signing is an important part of development, but there's also some risks associated with code signing. Kind of articulate some of the challenges or problems with code signing.
Sure. Let me give you a little context to put this whole subject matter in context with Venafi and why we exist.
Right.
How would that be?
That's perfect.
Okay. So you got to think of it as two actors on the network, people and machines. And people use usernames and passwords to identify themselves to machines. And then machines have to identify themselves to each other, but they don't use usernames and passwords. Right. They use machine identities. And we know the number of machines is going through the roof. They all need identities. And we spend about $10 billion a year protecting human identities and just getting started protecting machine identities.
Yes.
And this is bad because Gartner points out all the time, 70% of network attacks will use stolen or compromised machine identities in 2020. And the number's just catching up to that right now. So we created the technology that protects machine identities for the world's largest, most digitally transformed, security-conscious companies. Now, the reason this is important and relevant is that a machine is not only a device, it's a virtual machine, which means it's software.
Yep.
It's a container,
Yeah.
a microservice, a .exe, an algorithm, code, blockchain. These are all machines, and they all have identities associated with them, whether they're SSL, TLS certificates, whether they're SSH keys, or code signing keys. And so this is where we intercept with it, because in the world's new corporations, it's all made of code. These things are all code.
Yeah. Everything's just code now.
Everything's code. Everybody's coder. So when you create a machine out of code, how do you know you trust that machine? How do you know it's your machine? How do you know where it came from?
Right.
And how do you know what it's going to do? So the practice has been over the last probably 15, 20 years that you sign the code. And you sign it with a code signing certificate. And what that essentially is like a birth certificate for a piece of code. And so you put it on there, and then you know the provenance of it, you know where it came.
Right.
And because of the magic around that, you also know if it's ever been tampered with. So it was certified good at birth if you go through the process, and then you can tell if it's ever been changed, which is like critically important because you got all these people running around writing code now, and it's starting to execute on behalf of the corporation. How do you know if you're a corporation, how do you know it's my code? How do I know if I want it to run here? And this is what code signing is about. So that's a basic primer on code signing.
So I'll give you a great example because Paul did this. He left the API open to the Kubernetes environment up in AWS. And next thing we know, there's a new container up running on our Kubernetes cluster. Right? Yeah, I didn't want that there. Right? And that is a very valid use case of why signing is important, because if I had my signatures, my code signed in my containers, and it knew that it was supposed to be on that Kubernetes cluster, for example, and they knew those identities, then the ability potentially for somebody to drop a new one on there could have been blocked or stopped, or at least
that's
something.
The whole point.
Yeah, exactly. And when we see this proliferation of containers and containerization in cloud, and we're taking what was once a big monolithic application written in a single language, and then
break it up into
lots of pieces with lots of different languages on lots of different areas. I mean, it could be running on-prem, it could be running in Azure, it could be running in AWS, Fargate, ECS. The list goes on and on and on. This problem is only exploded and expanded.
The complexity has just gone through the roof.
Correct.
And what we typically think about a web app, where you click on things and you go to boxes, that used to be monolithic, one web server. And now there might be 100 web servers involved in that. So you click here, and to get the customer number, it goes there. To get the balance, it goes there. To get your history, it goes there. All this in there can be everywhere. And so it's like, okay, how do we secure this thing? And it starts with the code that you run, you can trust it.
Right.
And the way that programmers do this, and the way they have done it, is they will either, in all development environments, have a code signing capability. So you can sign code.
Right.
So the developer will go get their own certificate, or they'll go to, GoDaddy or one of those places, get it. They'll set up their own little vault and they'll sign the code, right? Well, then where's the key? It's on the developer's laptop, right? And so you got a whole bunch of developers doing that. The upshot of that is those things are easy to steal. And so there are about 22 million pieces of malware out there in the wild right now that are signed with stolen or forged code signing certificates. Because, like you said, if it's got a code signing certificate on it, if it's signed code, the first check is it signed or not? Yes or no? Do I trust the root on which it's signed? Yes or no? I do. It's a stolen certificate. Nobody knows. Let it run, and it's malware. And so there's the big problem.
Right.
There's this thing called key sprawl, and the developers of the world, these keys are like everywhere.
Yeah.
And so InfoSec is going, oh my God, we're creating all this code. It represents, it's like Intel or HP or whoever, and it turns out to be malware. Reputation problem, all kinds of problems.
Right.
So that's one of the problems. The other problem is, I mentioned that developers want to sign their own. So they go get their own certificates and they set up their vaults and their own little workflows. Why are they doing that instead of building apps that build value for their organization?
Right.
So there are the two problems. One is this thing slows developers down. Oh, by the way, there are some code signing things out there where you upload your code. So you upload, a big piece of code and it will sign it and do other things and bring it back down. That could be a day or two, right? And so this is old school. It's it's
old
all
school.
what used to happen.
You don't wait a day or two because people are releasing code like multiple times a day.
Multiple
in certain
times
cases.
a minute.
Yeah.
Yeah.
Depending on the organization.
Right.
But I mean, the days of waiting days or weeks are gone in this space because people are releasing code daily, if not multiple times in a day.
Right.
And so you need tools and processes that can keep up with that speed.
Well, and your earlier point was there was a monolith and you had a make and build process to build the monolith, and you release the monolith. But now what we've done is disintegrated the monolith or fractured it into millions of little pieces. All those things need to be signed. And all those little pieces change all the time.
All the time, yeah.
And so there's the big problem. Developers are going too slow and the keys are sprawled everywhere.
Right.
So we saw this problem because we're smack in the middle of machine identities.
Right.
We saw it about 4 years ago, and we've been working on it ever since. And so we just introduced something called next-gen code signing. And what we've done is created something that we've patented, which is a way to create a really cool cryptographic service, a CSP, where when the code signing engine that wants to sign the code needs a code signing certificate, it reaches out to our API.
Okay.
And what we do is we sign a hash and send it back. And then this hash gets associated with the code. The code doesn't have to move. The developers don't have to think about it because it's in their pipeline.
Right.
And the security guys know where all the code signing keys are.
Got
so
it.
it helps the developers go faster and it eliminates key sprawl. And so this is like huge because now everybody's a coder and everybody's saying, well, how do I sign code? And the InfoSec teams are saying, well, we'll send you code signing key. It just doesn't work. So we solved those problems.
So is it something that you embed into the IDE or into the build system? How does it actually get to your service? It's an API, but
it's an
from
API
a deployment
call. It's an API call. We have all kinds of different ways that it gets interfaced. So to call our API, embed a snippet. There's some open source stuff, all this kinds of stuff. But the point is, the Windows, the Java, you look at it, the Go, all those development environments, they've already got code signing built in.
Got it.
They just don't know where to get the key.
Yeah.
And so what they do is when they need the key, they call out
us.
to Venafi.
Got it. And then you have all the keys centralized, so you know where they all are. Right. So security's happy because all the keys are centralized and they're not sitting on developers' laptops.
They're auditable, all auditable
devices. Yeah.
Right. You can and so if something shows up in the wild with a signed as, say XYZ Corporation and corporation says that's not ours, say, look, we didn't sign it.
Right.
So it's really important.
But it also helps with key revocation, right?
Totally.
Because if a key does get compromised or something happens and you need to revoke it, you can do that easily if it's all centrally managed and housed
Right.
versus trying to figure out, okay, where's that key at, right? Whose computer is it on?
Or if you want to set up your system so that they'll only execute code that's signed by you,
Hmm.
then what you have to do is you have to have really good control over those things. You have to be able to check back and say, is this valid?
Yeah. Are they
Yeah.
still
Yeah.
valid
So
keys?
all the problems that exist around an identity. So if you have a driver's license or a passport, they may expire, or you may need to expire them.
Right.
Or you may find something where you didn't expect it to be, so you better expire everything
Yeah.
and reissue it. You know,
Yeah.
there's all kinds of things. There's so many corner cases in identity,
Yes.
and we need to think of machines, code as things that need identity, just like humans do.
Hmm.
Machines do, and that's the only way this world is going to unfold in a way that we can trust it.
Yeah.
Because right now more than ever, machines are making real-time life and death decisions about you and
Hmm.
I, not in Syria and Afghanistan, but on the streets of Las Vegas.
Hmm.
Because if you think of a self-driving car going down the road driven by what? A machine, a piece of
Hmm.
code, and a truck pulls out in front of it unexpectedly. It's got less than a millisecond to decide, do I crash in the truck and kill the occupants of the car, or do I swerve on the sidewalk and kill the pedestrians on the sidewalk?
Hmm.
It's not going to check back with anybody. It's not going to ask a human. It's going to make that decision. So that code, how important is it that
Hmm.
we know where that came from?
Right.
That code has an identity. It's the one we expect to be on there. We
Right.
know what ethics and morals were brought to bear to code those kinds of decisions now that machines are making life and death
Hmm.
decisions. The identity of these machines is skyrocketing in importance, and it's still not something that's on most people's mind.
Yeah. No, Bruce Schneier brought this up at InfoSec World earlier this year about the need for this, that certificates and the ability for machines to communicate to other machines and create those that authentication
Mm-hmm.
is going to explode. And you're talking about the same things. We're just expanding that concept of a machine all the way down to the individual pieces of code that are embedded in your application that need to communicate to other components.
That make up the application.
Yes.
Yeah.
Yeah, because there's so many components now embedded in these environments. You're pulling down containers that already have all these binaries and libraries embedded in them, and then you're building your custom code on top and understanding all those pieces and who signed them when to make sure that they're still the right
And
valid
think
ones.
about devices or machines that get embedded into humans, whether
Mm.
it's a pacemaker
Right.
or an insulin pump
Right.
or many, many things. You're going to want to know that the code that's running on that is actually the code that you think is supposed to be running on that. And therein lies again the importance of and the power of having an identity. And once you have an identity, we know it wants to be stolen, so you better protect it.
Right. So when I think about value to the customer, I mean, obviously visibility,
Mm-hmm.
figuring out where all your keys are and making sure that they're all centrally managed. You talk a little bit about developer friendly, and I think that is just, it has to be easy for development. Otherwise, it's not going to get adopted.
So have you read the book, The Phoenix Project?
I have not finished it.
You've got to
Paul,
read it.
yeah, I know Paul's read it and he talks about it all the time.
Okay, so anyway, there's a persona in there that's a CISO. They call him the Minister of No, John Pesci, and everybody doesn't like him because he slows everything
Right.
down. And so InfoSec has always been sort of the enemy
Mhm.
of go fast because they always say
No.
go slow. So what we're doing with our InfoSec teams around the world, and we've probably got, close to 400 now of the world's largest corporations, all the big banks on 5 continents, all the big airlines, all the big card companies, everybody that's really moving into digital transformation. We're saying, set up a service, become a service provider to your customers, and we provide them the ability to completely automate everything that has to do with certificates and keys, machine identities for DevOps, for things like F5s, for now code signing. So set up the service, hang out the shingle, say it's available here. And then what happens is when somebody says, "Yeah, I don't want to do that," then you just give them the policy manual. Say, "Okay, do it yourself. I'm fine with that.
Yeah.
Fill your boots.
Right.
There's the policy manual.
Yeah.
But you're on your own. Or use my service, and then I
It's
will take
taken
care of
care
the
of.
auditors,
Yeah.
and I'll take care of all that stuff. You'll go faster. I'll be safer. I'll be happy. We're in it together."
Right.
So set up a service and give people a choice, and it's actually working. And so it's fun to be able to help InfoSec teams become partner
Right. With
to
the
help people to
business
go fast,
and not the
not
prohibitor. Yeah.
the
Yeah.
minister of no. I
Right.
love that. I
Yeah.
mean, you should read finish the Phoenix Project.
Yeah.
Really good book because it talks about the what I call religion and philosophy of
Yeah.
DevOps, right? And it's a different way of thinking.
Yeah. Definitely. Definitely. If people want to find out more about your new code signing capabilities, where should they go?
Go to Venafi.com, www.venafi.com, and it's very straightforward of how you learn about the outcomes that we give to people, like help them go faster or avoid fraud and misuse or avoid outages. Outages is a really big thing, and it's really a good way to learn about this part of the market. A lot of people, it's really interesting. Go to some of your friends and say, "Do you know how a toilet works?" And they're all going to say, I know how a toilet works. And they say, well, explain to me how a toilet works. And they don't know, right?
Mhm.
What happens is a lot of people think they understand stuff, but they know somebody that understands it. And so they'll say, well, in their mind, well, I
Right.
know that
Right.
person, so I get it. Or it's on Google, right? But they don't get it. This is where this is. People don't understand the importance of protecting machine
Right.
identities. So go to our website. You can learn a lot more about it.
Awesome. Jeff, thanks for
Thanks,
joining us.
Matt.
Thank
Really
you.
appreciate it.
And thanks for watching. We'll see you soon.